Hello class and welcome to Math Minutes video lesson number 47. We're going to start looking at functions. So turn in your notebooks to page 9 and we will get started. A function is a rule which modifies a given number. In other words, if we start with an input and apply the function, we get an output. For example, we have a function or rule to add 3 to any number. So if we apply that function to the number 2, we get the number 5. If we apply that function to the number 3, what would we get? We get the number 6 because our rule is to add 3. First we added it to 2 to get 5. Then we added the 3 to the 3 to get 6, and so on. In these examples, the 2 and the 3 are input numbers because we're putting that information into the rule, and the answers of 5 and 6 are output. This function could be written like this. So this is function notation, and it is, you say it like f of x. So the function of x, or f of x, equals x plus 3, because our rule was to add 3 to any given number. So our variable first was 2, and then it was 3. And it would look like this. When our input was 2, we would replace the x's with 2. And then when our second input number became 3, it looks like this. Because the function of x in this case is 3, and this was our function to add 3 to it. The output of each function is called the dependent variable because it is dependent upon what the input value is. We have no idea, no way of being able to figure out what an output is. We might have a rule, but there's no way we're going to be able to figure out what the output is unless we have an input. So that output is dependent. It depends on having a number input to the rule. The input of each function is called independent because it can be whatever it wants to be. So let's take a look at some practice and a little more explanation of function. So again, how would we read this? I would say f of x equals x minus 4. What's my rule? My rule is that whatever number I put in for x, I'm going to subtract 4. So if I'm putting in 10, and I'm subtracting 4, 10 minus 4, what would my output be? 6. Well, what if I input 9 and then I subtract 4? My output would be 5. What if I put in 6? 6 minus 4. Well, my output in that case would be 2. Well, what if I put 2 into this rule? 2 minus 4 is negative 2. So you see my output values followed the same single rule of minusing 4, but my answer depended on what value I put in. So let's try the next one. What is my rule? I'm going to multiply x by 2 and I'm going to add 1. So this function is 2x plus 1. Well, my first input value is 1. So that would be 2 times 1 plus 1 is 3. My second input is 3. So I can say 2 times 3 plus 1. 2 times 3 is 6 plus 1 gives me 7. What if my input is 5? 2 times 5 is 10 plus 1 would give me 11. What if my input is negative 2? 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. So here's another way. Rather than just listing, because that can be a little bit confusing, we can use an XY table. And if you recall, you may remember seeing these when we were graphing coordinates, when we were having a linear equation and you substitute values in for x and you end up with a y and you're able to plot points. You are actually using function function stuff right there. So here is our next function. F of x equals 2 times whatever x is minus 1. And we have a value of x being 3. What are we going to do? We're going to substitute that in right there. This, I'll take just a moment to note. You can always think of this as being your y. You could also rewrite this as y equals 2 times x minus 1. So let's put a 3 in there. 2 times 3 minus 1 is what? Well, 3 minus 1 is 2. 2 times 2 is 4. So if I input 3, I get out 4. Let's input 4. That's going to give me 2 times 4 minus 1. 4 minus 1 is 3. 3 times 2 is 6. So when I put in 4, I get out 6. Let's put in 5. 2 times 5 minus 1. 5 minus 1 is 4. 4 times 2 is 8. When I put in 5, I get out 8. Let's practice on one more like this, filling in our table. Well, this time, x is negative 1. We're going to substitute that in right here. 3 times negative 1 plus 2. How is this one different from the function before it? Well, these were in parentheses, so we had to do that first. This time, we're going to do this first and then add the 2 because there are not parentheses around the x plus 2. 3 times negative 1 is negative 3. Negative 3 plus 2 is negative 1. And it's okay to end up with the same numbers there. Okay, 1. Instead of negative, we have a positive 1. 3 times 1 is 3, plus 2 is 5. If I put in a 1, I'm going to get out a 5 according to this rule, this function. Let's put in 2. 3 times 2 plus 2. 3 times 2 is 6. 6 plus 2 is 8. And there we have it. We've been doing functions and we can use a table to organize our answers. Well, how can you tell if a set of inputs and outputs represents a function? Well, look at the following tables. Well, let's back that up a minute. What do we need to know? If it represents a function, it means that the numbers have to follow the same rule. Let's think about that. Every time you see the word function, think rule. So how can you tell if a set of inputs and outputs are using like the same rule? Let's look at the following tables and determine if it illustrates a function. Well, what do we have to know? Well, what's going on between these two numbers? If we put in these numbers, we're getting out this. What's our rule? And it has to be the same rule for each pair of numbers. Well, I can see that to get from 2 to 7, I'm adding 5. And let's test it. Is this my rule? Is 4 plus 5, 9? Yeah, okay, it works for that one. Is 6 plus 5, 11? Yeah, it works for that. Is this a function? Yes. What is my rule? Add 5. How would I write this in function notation? It would be f of x equals x plus 5. Because my rule was adding 5 to whatever my variable, whatever I decided my input was going to be. So let's take a look at this one. Is this a function? Well, the first thing we have to do is find, is there a common rule? What is happening between the 2 and the 1? Looks like I'm subtracting 1. Let's test it. Is 4 minus 1, 3? Yeah. Is 6 minus 5, or 6 minus 1, 5? Yeah. These are all minus 1. Is it a function? Yes, because it's all following the same rule. What is my rule? We are subtracting 1. How would I write my equation? F of x equals x minus 1. Whatever I'm doing to that number, that's my rule. Okay, let's take a look at this one. What is going on between these numbers? Well, 2 plus 2, I could either be adding 2, I could also be multiplying by 2. Am I adding 2 here? No. Am I multiplying 2? No. 6, am I adding 2 to get 9? No. And there, I'm only going like up 1 here. I'm going up 3 here. These are not following the same rule. Bam. Function? No. Let's take a look at the next one. What's going on between 2 and 5? Well, I'm adding 3. Let's test it. From 4 to 9, that's plus 5. 6 to 13, I'm adding 7. These are different, but is there another way I can get consistently from 2 to 5? One thing we can do is, well, if I doubled each number, what if I did a times 2? That would give me 4 and then added 1. Well, it works for this. How about this one? 4 times 2 would be 8 plus 1 is 9. All right, I'm onto something here. 6 times 2 is 12 plus 1 is 13. So what my function is I am multiplying the input by 2 and then I'm adding 1. So is it a function? Yes. What's my rule? I'm going to times by 2 and then add 1. So how's that going to look? F of x equals, how do I multiply something by 2 and it's an unknown? I would write 2x. My unknown times 2, and I'm taking all of whatever that answer is and adding 1. So that's what my function would look like in this particular table. And it looks like we have another way that we can find out if something is a function. Another way to determine whether a set of points is a function is to apply the vertical line test. Vertical line to a graph. What does that mean? Vertical lines go up and down. If I draw a line here, how many times did it cross this line? Only one place. What if I put a line here? It only hits it one time. This line is a function as opposed to, well, I'm going to do that down here. That's the vertical line test. If it only crosses your line one time, then it is a function. If you can draw a vertical line anywhere on the line and it only intersects it one time, then it is a function. Here's an example of what could something look like that's not a function? Well, what if I had a shape that looked like that? It's some sort of graph that looks like that. Well, if I apply a vertical line, it's intersecting here and here. That means it is not a function. I can have a graph that looks like this. Is it a function? Well, I can draw vertical lines and it's only intersecting at one place. It is a function. It's not linear, it's not a line, but it is still a function. So there you go, little introduction to functions, what the notation looks like, and how to test whether an equation or a set of points is representative of a function or not. Remember that function is just another way to think about a rule, something that you are applying a rule to one thing and getting something different out after you apply the rule. There you go. Good luck with your homework, and I'll see you soon.